Okay, hello everyone. My name is Ye Cao. I'm a master student from Rose Lab. Today, the topic I'd like to share is to porting Chrome OS to RISC-V. And in this project, we are working with engineers from Red Hat who are very experienced in platform enhancement. And in the following minutes, I will share the main summary of my work. Okay. Our target is about Chromium OS. Chromium OS is the developed version of Chrome OS, and it's a free and open source operating system. And also, the Chrome OS is developed for running web applications and browsing the internet. One of our motivations comes from PicoRail. PicoRail is designed to be an open source RISC-V platform, as you know, and Chromium OS will play a very important role in PicoRail software stack, since it will act as the providing a rich OS execution environment as shown in this figure. And let us talk about some features about Chrome OS. So firstly, Chrome OS is a web-thin client operating system that relies primarily on servers to host the applications and the related data in the cloud. And also it has a very strong support for Linux kernel and run applications in the virtual machine. And also, in the second part, the Chrome OS brings rich software ecosystem. The user can simply access the virtual desktop through and access the apps. And apart from this, Chrome OS also has links with Android system and indicate the linkage with the Android apps and the Chrome OS. And thirdly, Chrome OS has a very great feature about the protection about security. And a verified boot module is contained in Chrome OS firmware. And we are also trying to port these features to RISC-V. Okay, and let's talk about our methodology. In this project, we use native build during all the porting process, and we use Chromium and Chromium user emulation to bring a native RISC-V environment. And from x86 to RISC-V Fedora Linux, we use Chromium to first enter a RISC-V environment, and we enter the build environment, which is RISC-V Gen 2, to use the container. And since the Chrome OS is developed from the Gen 2 Linux, and we enter the RISC-V Gen 2 and start building. And also, we have a try on cross-building for a very long time, about half a year, but it turns out not work. And we conclude about some reasons for this result. And in very large operating system, the dynamic dependencies are very complex for cross-build, since the build environment, while the compiling environment and the build environment and the environments in the real runtime OS might be very different. So the dynamic dependencies will count much for the cross-build. And secondly, the Gen 2 package management will build package from source code. So building scripts might be different from cross-compiling and the native compiling. So some packages even need us to create a brand new script for cross-build. So this is not very possible for every single packages, since the packages, there are thousands of packages for building. And also, while porting, we just use similar way from the original building flow from the x86. And of course, we made some modifications from the Chrome OS original building SDK. And our main work contains 3 stages. In the first stages, we creating a change root environment and enter the change root as a container and enter the native build environment. And in this environment, we start board initializing and start installing the packages. And finally, we just building the OS image. And the original building flow is like this. It contains about 4 stages and similar about the main 3 stages. And while as RISC-V porting, the high level purpose are similar, but there are still a bunch of differences. So the mainly differences is in the first part, since we don't have a change of image about RISC-V, so we need to build the change of image from very beginning. And we start from a Gen 2 file system. Firstly, we should add profiles, add Chrome OS profiles as well as RISC-V profiles to the file system. And we need to initialize the RISC-V toolchain, since RISC-V toolchain is very different from the binary toolchain in x86. And after initialize the toolchain, we need to build all the packages in the dependency tree to check and to make sure it can work. And for this reason, at the third stage, the installing package will be the second time for our building packages. So at the second time installing packages, that will be more easier for us to build the packages, since we have already built all the packages while creating the change root. So before our detailed methodology, let me just give some introduction about the package manager of Gen 2, as well as Chrome OS. Portage is the package management system used by Gen 2 Linux and used by Chrome OS, and its main command is like this figure, and the image is the command. It's the interface to the EBO to manage resources, and it can manage resources and also resolve the dependencies. And in the blue square, here is the location of building scripts in the repository. And also a very important feature is about use flag, just like this red line. And using these flags, we can just indicate to include or exclude some specific dependencies while building. For example, in this figure, we can say that we want to build a Python package, and this package must include GCC. And we can build this package in this way. And the use flag is very important for our dependency management. And also it can be configured while requiring dependencies, just like this. And during our whole porting experience and my main timeline is like this way. And I had some tries to modify the SDK script first, since we need to modify the SDK from the very beginning. And before we enter in the change root environment, we need to adjusting the profiles, just as this green matrix. And after handling the profiles, the main part of our time is about building packages, including the toolchain packages, and including adding RISC-V support, including deal with the package dependency. And the building process is very time consuming. For example, the GCC package takes about 70 hours over almost 3 days to build. So a very painful lesson is about the environment reliability, since we have a power cut during our building, and the GCC must be built from the build again, and it really takes time. So in the future, might we need to find some chances for distributed build and maybe to create some snapshot or whatever. And during this porting work, I have faced a lot of challenges, and the challenges mainly about 2 parts. The first part is about the package management, as the Gen 2 style and the Chrome OS style is very different, and we need to start from a Gen 2. And there has very complex issues about the package management, and also about RISC-V support. Since we are going to port Chrome OS to RISC-V, and about the RISC-V support on some packages, there are many issues we face, and since many packages still lacking of RISC-V support. And for the first, about the package management, the first part is about version conflict. So while we are porting packages to RISC-V, we need to modify some versions about the packages, and this will lead to versions conflicts about package, and we need adjustment on package dependency. And since the package dependency issue came at the same time about our port of RISC-V, so we need to do adjustment about the tag, about the use flag we just talked about. And this is a figure about our modifications on use flag. We can see that most of the conflicts about Python, since recently the Python 2 is not supported for the recent system, but at the development time of the Chrome OS, there are still a lot of scripts about Python 2, and dealing with these conflicts is very complex. And also we have some modifications on the LLVM target, also as well as the database and Rust. And about the profile adjustment. since we have a very clean profile, which is not work at the very beginning, and we need to add RISC-V support and to add to a Chrome OS style. And our new profile is combined both from Gen 2 and from Google's Chrome OS overlay. As we can show here, the architecture part of our profile comes from Gen 2. We modify this into Gen 2 overlay and link and symbolic link to Chrome OS overlay. And the Chrome OS overlay has all the Chrome OS features over profiles, and we use it as our main repo in the repository. And the second is about the RISC-V support. Firstly, it's about Google source. Since Chrome OS is developed from Google, and there are a bunch of packages about Google, and it needs to be downloaded from Google Cloud. So the first of our very big issue is about the basic tool of Google. The workflow tool set has limited RISC-V support. And this is binary to only support for x86 and ARM. And we need to compile it in the RISC-V environment. And maybe we even need to bypass it and find the exact source code is download. And the second part is about find the minimum package set. Since a lot of packages is lacking of RISC-V support and are not very essential for us to build a shell version of operating system. So a very important part and practical part for us is to remove package dependencies. And here is a is a chart about our modifications on the root of dependency tree, the first level of dependency tree. We can see that only about a half packages remains on the unmodified, and about a half we just remove it from the dependency tree. The most of the part is about cross-compiling. Since we just build it all in the native environment, so most of the cross-compiling utilities we just don't need, and we just modify it, remove it. And some about Android and about Chromium, we don't need right now, and we just move it at first and to build the OS environment. And second part is about the upstream Gen 2 source. The upstream Gen 2 source has a very better case for RISC-V support. And we can see about this chart, most of the packages don't need modifications for RISC-V support. And some of these are architecture independent, and some of these that have already had RISC-V support. But still, we can see that some packages has still inefficient RISC-V support, and we need to modify it manually. And also, it has some potential issues for some cross-compile packages. Here is the Go case. Go has RISC-V support, but it can only cross-compile to RISC-V. And it may have some potential problems since the dynamic runtime library may be different. To solve this problem, we just specify the issues during our cross-compiling and make sure the dynamic environments between the compiling and between runtime are pretty safe. And here's our future work. Since we are currently finished most of our work, and it still remains some of the work for the bootstrapping. So the first of our short-term goal is to finish the whole porting work and to run the simplified shell version. And also, while porting, we will collect data and have detailed research on the RISC-V ecosystem to find the supporting situation of packages. And for the long term, maybe we need to find the GUI version Chrome OS to integrate with Chrome browser. And this is our long-term version. And thank you. That's all of my talk. And to have some comments or questions. Right now, we are run on the Chromium, and after successfully run on the Chromium, we sure need to port it to real hardware. Yes, we currently run on the RISC-V Chromium, and surely the Chromium is the emulator on the x86. But our goal is to port this operating system to RISC-V environment. Yes, right now we are run on Chromium.